recording is on. Did we talk about an exam, the second exam? Have we talked about that?
Yeah, we brought it up.
Okay, great. All right, so
we didn't cover it all. It was just mentioned.
just mentioned. Okay, so exam 2, right? So today is what, the 24th? Today's Wednesday, 24th. So what do you guys think about having the exam on April 5th? Really, we should have had it on the 29th, but since I'm only kind of mentioning it right now. April 5th, does that work for all of you? Plenty of time, right?
Yeah, that's fine.
Okay.
Yeah, that's okay.
All right, great. So yeah, so April 5th, we'll have the second exam. Remember, it's comprehensive from beginning of the semester to whatever we cover, you know, on March 31st. So as you can see, that's already in the calendar. So let's just, I'll update this a little bit. It says Blackboard there, but let's just leave it at that. You can expect a similar exam, maybe a little bit shorter, similar. So some questions could be similar to the questions from the first exam, and then obviously some questions could be from the second. The way I see exams is actually, you know, those are, if you study and have done the labs, those are easy points. So it actually helps you. All right, and it gives me another mechanism of measuring. So exams versus labs, it's a useful thing to have. All right, so yeah, let's agree to that. On April 5th, you will have your second exam, similar to the first exam. Remember, I always give you the extra time. No need to send to me, you know, the things, right? I already have you on a list. So if the exam is 2 hours, but it'll stay open an extra hour if you need to. All right, so that's basically the, if you have approved extra time. So that's really the plan, okay? So what we're gonna do today, if you remember, on Monday, we covered the file system analysis. There won't be any lab for that one, but just make sure you understand the concepts that we discussed. If you have any questions, ask me. The file system, of course, is central to Unix, and so, you know, we needed to talk about it, okay? Next week, we're getting very close to the end of the semester, right? And so one of the big topics that we still need to cover is monitoring. And for monitoring, it makes sense to talk, you know, to start historically from the simple network management protocol, you know, given that that is sort of the, you know, whether a company sells a product or not, or they use an open protocol, everything is coming from there. So we'll start that topic on Monday. I actually like this topic quite a bit. The lab is pretty simple and pretty fun. And then we'll talk about namespaces also, which is the account management. Namespaces is a general topic, but really the lab is account management. So you'll get that. And really those are the two main topics that we have left. And then a little bit of firewalls and security. And that's it. I mean, we are at the wrapping up the semester. Again, I remind you, work on your projects, the Hadoop project and the project A and project B. So project B, remember, I've been giving you ideas. Doesn't have to be very complex, right? Just find something in system admin in Linux, configure it, and demo it. Today is probably the last time we will cover scripting. So this is kind of a wrap up of general scripting. So I'm going to give you, you know, one final overview of scripting for sysadmin. After that, there will be a script for account management and a script for SNMP, maybe a script for firewalls, but, you know, just simple things, right? So. But today is really, you know, our last time to kind of, so I just want to spend today all day basically going over this. And then you can expect that from these examples, I'll create, you know, some, you know, few problems and these problems will, you know, some homework, but we'll see. So I got to create the problems. However, I want to stress, as usual, if you go to the GitHub, all the code that I'm going to discuss has already been updated here to the GitHub so you can just download it for your own convenience. However, I'll be typing it up on the computer just to kind of, you know, today is lab, so we're going to take it, you know, as a practice day. And, you know, stop me. I strongly encourage you to follow along. Type it up and then. So as you can see, a lot of the scripts will relate to things that you can do in Linux, right? So SSH, compression, a simple HTTP server, PDFs. What is a PDF? You know what a PDF is. It's a document. But if you remember, you guys were creating, logs and things like that when you were gathering information. But what if you just wanted to do that, automatically generate the PDF report, email it to yourself, and that way, you know, you have a more presentable report that you can submit to your supervisor or whatever. So this is really important. Geo-locate, we talked about this on Monday. You can take a look at that one. FTP, so you can see these are all services, right? So at the beginning of the semester, we started with, you know, servers and services, right? And so in Unix, in sysadmin, it's all about servers and services. All right, and then you can see here map redos. This is one of the ones we'll do today also. And then there's some file system ones related here, you know, how to search the file system, etc. Okay, so I may not do all of these. So what I would recommend is, you know, practice these, right? So sit down, practice all of these. Obviously, I will only give you like 3 problems. So I'm not going to give you all of these as homework. But, you know, given that this is kind of your last time, you know, where you have a big set of scripts, you know, kind of practice them a little bit. At some point later in the semester, we're going to go over Bash, and Bash is also, you know, for Unix, right? So I'll go over, you know, just Bash scripting in Unix, which is the other scripting language that's really important. All right, so that is basically the plan for today. All right, so let me go ahead and, so I've already pointed out that the scripts are already on GitHub. You can just get them from there. So let me go ahead and start the VM. All right, so I need to start my virtual machine. So let me do that. Give me a second here. All right, so we can just use the seed VM. That's perfectly fine. Can use that one. Given that these are scripts, we may need to have some services on as well. All right, you know, if you're using SSH or you're using FTP, you would need to have that service on. Okay, so just be aware of that. We'll just start with a simple one, kind of a warm, you know, like a warm up before we get into, you know, some that are a little bit more complex. And please, you know, stop me, you know, if I'm going, you know, sometimes something seems obvious to me that may not be obvious to you. Okay, so just stop me. So we are recording. I just want to make sure. So I'm going to share now the VM. So I'm sharing, you should be seeing the VM now. I'm going to open up the terminal. Okay. And I'm going to CD into the desktop. And I'm going to go in ITS 372. Oops. Oops. Right, and then we have all of our scripts that we've done so far, right? So we've done quite a few scripts, and then kind of we're going to wrap up this topic. So let's just start with, you know, like I said, these are just miscellaneous sysadmin topics. So let's start with a simple one. Let's do Let's do. Let's do a simple web server. So let's do that one. All right, hold on. Trying to find this. All right, so it's like at the very bottom of my my stack here, but I found it. Okay, so let's do a, as I said, there's no real order in these. They're just basically various services, and then what would be the scripts that you could do. So in this one, let's say that you want to create a simple web server, right? A simple web server, like an application that's available. So it creates a simple web server to serve contents of the current directory, right? So the idea, I guess, is you could create, you're in a place, in a organization, you want to make a folder available to everyone, and so you want to create a type of a web server linked to a specific folder. So let's say, I guess, in this folder, right, we have these files, right, and we want to access it. So let's create a script for that. So let's call this one, simple. Let's say simple web server. So the idea is that literally we're starting a service. Remember, services are associated with port numbers, okay? So don't forget that. That's why you did a lab at the very beginning of the semester where you had to look up all these services, right? Obviously, we're not gonna use one of those services because, port 80 or 443 are ports associated with web servers, but in this case, we're gonna use, another port number, another of the 65,000 servers, ports that we have available. So let's go ahead and start this. So I don't believe we need to install any libraries. So these are built in for Python. And so let's do import simple HTTP server. And import socket server. All right, so import socket server. Now we're gonna pick a port. So let's just create a variable port equal 8,000. And now we're gonna, create an object called handler, basically the thing that's going to handle or become the object for this. So it's gonna be a simple HTTP server. Oops. Simple HTTP server, which, from it we call the module simple HTTP request handler. Okay, so we use this object, and now we also will use the socket the socket object. So remember, we defined sockets as a combination of IPs and port numbers. So it's basically, it's an endpoint connection, right? And so that's what we're kind of creating, this endpoint connection to this process. So we're going to call it HTTP D. And if you notice, we're cleverly calling it HTTPD here in the code to imply it's a daemon, right? So a daemon, just like the actual Apache HTTP daemon. So here then we have socket. So we're using socket server dot TCP server, and we're going to initialize this, you know, as like that, right? So that's basically our socket. And then we have finally the handler that we just created. So oops, wrong. So let's do handler like that. Let me actually move this a little bit. All right. So then that's basically the object that is going to be listening. And now we can just say, we can print a little message when we run this so that we have some information. Serving files on port and then comma, and then, you know, port over here. And then we're going to do HTTP D dot serve forever. Okay, and that just means an infinite loop forever, like that. And hopefully that'll work. So that with the first thing we need to do is we need to run this. So let's try it. So I'm going to do Control X, Y. I'm going to do Python. So we might need root privileges for something like this. So we'll see. So Python. All right. So what does that mean? It means that the service is listening, right? It's listening. So now let's say that you did this on a server. Now you would only do this, of course, internally in your own company. You wouldn't do it, let's say, on the internet, of course. But here, you know, we've easily created this. So now let's go ahead and we need to reach it. You know, we're going to have to open up a browser. And in the browser, we can just type localhost, or we can try 127.0.0.1. And then we need to specify the port number. So we use colon, and I think the number was 8,000. So now I run that, and guess what? It works. Do you guys see that, guys? Does that make sense?
Yeah.
And what is this? So as I said, you know, you're working in a business, and you know the chemistry department says, you know, we need access to these files. Could you make them available just for tomorrow? And so what do you do? You know, this is one. Well, then you just send them, hey, here's the IP address of the server. Here's the port number. Just go to any browser. If you can ping that machine, you'll basically be able to reach it inside the network. And now you have access to all these files, right? So you have access to, you know, all your little files, you know, and there they are. So now, very conveniently, your the people in your company can have access to this information. All right, and that's it. That, you know, it's a simple way of writing scripts, and hopefully, you know, by now you get the point that whenever you're a sysadmin, whether you're a sysadmin for Windows or Linux, you would, you know, it's a lot of power to you to know this thing, right? It makes no sense to learn a lot of tools, let's say today, because first of all, by the time you graduate, those tools will not even be around anymore, right? So here, you know how it works inside, behind the scenes, you have the intuition, and then you can always either develop your own or understand other tools really fast. Okay, so that is an example of doing scripting or using, dealing with a service such as this, right? So the applications of this, as it ties back to the chapters, you can serve files, you can serve, for instance, a lot of policies, right? So you want to have all the policies for new employees, all training documents for new employees, kind of, you know, things like that. You have a server that, you know, so this makes it quite easy to do. No web development necessary, nothing like that. So that is a simple web server. Okay, so we're done with that one. The code should be on Brightspace or just follow along. Let's see what else. Since we are here, let's see now. What else do we want to do? All right, so another example that we might want to try. Now we talked about the case Aurora. Okay, the case Aurora was, if to remind you, on Monday we talked about it, right? So the idea was people received, what do you call it? Phishing on the email. They would click on the link, download some software, and then they would have a malware installed on their computer. Malware would contact another server out in the internet, and you know, that was a problem. So we talked about how geolocation could be a way to deal with that, right? So for the geolocation one, I'm just going to go over it. Since this could be a project, I'm just going to discuss it. So I'm going to switch back to, you should be seeing now the GitHub. And in the GitHub, you can see I already provided starter code for geo-locate. So this, again, would be the code associated with the Aurora thing. So the way that the code works, let's take a look at it, basically. So in essence, you know, you have some data, right? So you have some data. Notice that this has an extension PCAP. You should be familiar now from your Wireshark assignments that PCAP files are basically packet captures, right? So they're basically packet captures. So here you have some data. You grab that data. Maybe you collected that data, right, from your Wireshark is listening, or TCP dump is listening every day, right, or at night or at any time. You just leave a server kind of just listening there. You tap the line that goes directly to the router. So a network tap is a really nice tool that I recommend all of you should own one of those. A network tap is just a little device. It's like a little switch with 5 ports, where ports 1 and 5 are usually mirrored. So therefore you can, it's like you can grab a line, cut into it, right? But then you can connect a scanning computer on port 5, and you can basically listen to anything that's happening, right? So you can put that tap anywhere in your network. You just need 2 cables instead of 1 to cut, right, the cable. And then after that, and it's inexpensive, right? So it's tiny. You don't have to have like a advanced switch for that, right? So you can just have that little tool. So let's say that you did that. You tap the line that goes to the router, that goes out to the ISP. And so now you can listen to all your traffic there as it's leaving the network. So then you have some kind of scanning, you know, it's called usually, the terminology is like a sniffing tool. So the sniffing tool is listening to the traffic going out, the packets, and then you Wireshark or TCP dump, you just save them as a PCAP file, which, you know, you should be familiar with this concept now because of the Wireshark labs. So then after that, you then grab that PCAP. Notice here, there's a library, DPKT, right? And you can see that that library has been provided here. DPKT is just a library for like network, network packet analysis, basically, is what I would call it. It understands PCAP format, and so it can help you with that. The other library is something called geo-IP. And as you might imagine, geo-IP is nothing more than a database for IP addresses in the world and their associated countries. So like the country code, it even gives it at the city level. So like it would say Hammond, Indiana, for instance, for PNW. And so as you can see over here, you grab your packets, right? You grab your packets, you basically read them, and then DPKT PCAP, now you pass this to a function called print PCAP. And you can see that function is right here. Print PCAP is the function. And then all you have to do is you kind of analyze, right? You analyze the different packets, right? So you're going to take, in a for loop, all packets in PCAP, and then you're going to check some value. So I'm going to go in, I'm going to use DPKT, Ethernet, grab element, grab the data, put it in IP, and now you can look for IP source, IP destination. You guys see that? IP source and IP destination are what? All packets have two IP addresses, right? The source where the packet was generated and the destination where it's going. So if in your company you have packets that are coming from any computer, right? One thing you will know, first of all, is which computer is compromised, right? Because you will know which packets have the destination in question, so you know the source. So that's one good thing about it. That allows you to pinpoint in your network the compromised computer. The other thing is, if you visualize or if you get a report, you know where your packets are going, right? So you know where your packets are going. So in this case, all we need to do is we take IP destination, or DST, and we plug it in here into the function called retrieve geolocation. And then that just prints it out. So now if we go to retrieve geolocation, you can see that what we need for this is we need this library, GI, right? So GI calls geo-IP, and then this is just a database. So you can see the .dat extension just basically has like a database of, what do you call it? IP addresses and what country they belong to, what city. So now when you pass this DST, that's an IP, the destination IP address, that's right here. And again, you just grab IP and you literally treat it like almost like a SQL database, right? So you do a query. So look up this IP in the database. You see that? So obviously you'll need to now I should say you need to install these two programs and you need to download this database. These do not come pre-installed with Python, so you just have to install them. But this is a sysadmin class. You should be able to install things in Linux now. All right, so now once you do that, it gives you a record. So for that IP address, it's going to tell you what city and what country that, according to the database, those are associated with. And then therefore, now there could be that some are unregistered. So if it can't find them, it'll just say unregistered. But if it finds them, it'll give you the city and the country. And then you just print it, and that's it. Very simple. Think about it, right? So, a problem that seems so insurmountable, right? Of, where's the malware? Is there malware in our network? Well, if the malware, usually if they're stealing information, you have to send it somewhere, right? So it's initiating from your network, sending out data into the web. And by the fact that you never do business with, some country in the world, Germany or whatever, so then that allows you to pinpoint and become suspicious about that traffic, right? So in particular, if you always, if you start this before the malware arrives, like let's say that you develop this and you have a little reporter map of this, you know, then this becomes almost an anomaly detection system. So if you think about, I don't know if we did a lecture on intrusion detection systems, but that's the topic of your network security class. I'm sure when you take 454, it'll be covered there. And so if you think about it, this is an anomaly detection system because you develop an intuition of, okay, my traffic, you know, goes to these countries, or this part, you have a map of the world where everything is going. And then all of a sudden you have this a lot of traffic going to this country at very strange hours, et cetera. That should raise an alert. You know, you could even, like if you had a map, right, you could highlight in red, you know, why, you know, this is red, this is strange. So it becomes a type of an anomaly detection system, and then you can detect possibly, you know, like in the case of Aurora, you can detect not only which machines are compromised, but also before that, that there is a compromise in the organization. So that's it for this script. Are there any questions, guys, on the case Aurora?
I don't have any.
No questions? All right, so good. So hopefully this is clear. I always think that's a fun case. I strongly encourage you guys to try to do this on your own. It's not homework, but I do encourage you to try to do that one. All right, so let's do another one. Excuse me. All right, so let's see. All right, so now let's look at a few things like creating backups of things, right? So to create a backup, and I think we've done backups before, what do you want to do? You want to, let's go back to the virtual machine. Here we are. We can close this one and just go back to, oh, so you can see also, this is still running actually. And so I'm going to just stop that process, hit clear here. All right, so let's think of a backup script. Let's call it that. I don't know that, excuse me. Now, the way that this would work is that you would, of course, need a cron entry, right? So you need a cron tab or cron entry in your system to run backup at specific times of the day, right? But then that cron entry would call a type of a script. So let's do like backup.py. So nano backup.py. All right, and now you want to think about what you would want to do, right? So in this case, you want to maybe copy some files, right? You want to copy some files. So there is a library and compress them, right? So, you know, if you're creating backups, you probably are doing that all the time. So you want to be a little bit efficient. So tar is the compression algorithm, or a compression, I guess, a process program in Linux, right? So you can tar your files. So zip also works, but let's do tar. So in this case, what do? Let's do import tar file, and then create some kind of an object. Let's call it tar. I'm going to say tar file dot open, right? And then we need some file that we want to backup, right? We need the name of the file. So let's say that we want, for instance, we want to create just some names. Let's call it large file dot tar. So we create, you know, a compression type of a file, and then we're going to say that we're going to write to this. Do W, and then after that, all I have to do is I need to add things to the tar file. So I'm going to say tar add, and what do I add? Well, here you need to specify the file that you're going to add. So I think we just wrote a script. What was it called? It was called simple. You guys remember the name? Was it HTTP server?
Yeah.
All right, so simple HTTP server, I think that's what it was. So we're gonna, you know, tar this one in. We're gonna add it to the file, and then that's pretty much it. Then we just do tar.close, and hopefully this will create our large file tar. So let's do that. Control X. Let's do an ls, simple web server. There it is. So now I need to run this one. Python. Okay, gave me an error. Oh, it's simple web server. Okay, so it ran. That's a good sign. And there it is. There's your large tar file. Okay, so you create this. So that's your. It starts to create this file, and then you can basically add other things into it. Sure. So you want me to go back to the code? Sure. All right. Oh, not this one. I'm sorry. No, it's this one. You guys seeing it? Remember, all of these are on the GitHub, by the way. Any questions, guys?
Not at the moment, at least.
All right, great. So another thing that we could do is, let's say that we want to actually do something a little bit more meaningful. Like, for instance, we want to copy the entire contents of the etc folder. Right, so for that, we need the OS. So we bring in the OS here, module. And let's change the name of this one to etc backup. So etc backup, okay, .tar. So tar file open. And now what we want to do is first we need to walk through the entire etc folder, right? Grab it, and then we're going to add it to our tar file. And that's it. That's how we can create a backup. So I'm going to do for root, comma, directory, comma, files in os dot walk. And what do we walk? We walk the etc. How do I tell it that? Well, root and then etc. You can see that there. So we should have read privileges, right, for all those files, even though that's a pretty important folder. We're not going to modify it. We're just, you know, reading it. So then what we do is for file, we have all the files in files. So we say for file and files like that. Pretty simple. And now we're going to join. So I'm going to do 1, 2, 3, 4. I'm going to do full path. It's going to be equal to os.path.join. Join. And then the root just assigns any path that's needed there. Root, you can always print these out, and file. So that way we have the path and the name of the file. Now we join them to have the full path, just very much as we would have with PWD, basically. So this is like the PWD command. And then now we have this one, and all we have to do is our tar.add full path. That, right? And so this will allow us to add all of our files in there and create our backup. Then again, you would run this with some kind of a cron job, so a cron tab entry, and you close the tar, and that's it. So now let's go ahead and run it. Make sure it runs. Clear. And there's more things that you can do with this. This is just a very basic. Oops, there's an error. Permission denied. Permission, well, sudo then. And there you go. So it worked. So then I'm going to do clear ls-l. There it is. etc backup tar. So we've created our tar file, and then now you can store this in your environment. And that's the way that you can easily create backups. So every morning at 2 a.m., you run that cron entry, which calls this script, and now you have you've backed up some files. Any questions on this one? Let me bring it up again. This one. Yep, there it is. All right, let's take a 2-minute break. Let me, let's see, I'm gonna stop. I'm gonna. All right, so we've had a little bit of time to look at that one. So if there are no questions on this one, let's take a look at another example. All right, so that one was tar or compression. That one was tar or compression, so let's see what else we can do. Let's take a look at, let's try, let me open up Python here, and I'm gonna do import report lab. Let me see. Okay, so it doesn't find report lab. So then I'm gonna do the following, I'm gonna exit, and I'm gonna do sudo apt-get install Python Python report lab. Okay, so let's see if that works. All right. Okay, so it seems like it installed. So now we can go ahead and try this. I'm going to repeat the exercise. Python import report lab. All right, so we have the library now, so we can use it. So I'm going to go ahead and close out of here. Questions? Okay, so let's create now. This will be for creating little reports, right? So we're going to try to create little reports in, like if you were collecting log information, etc. So let's do, let's create a script. So nano create report. We create this, of course, from Linux data. So for instance, we can do now from report lab dot PDF gen. So it allows us to create a PDF. And from that, we're going to call something Canvas. Canvas is just like in Word, that template that we get where we can write things. Right, so now we are going to create some function, report, okay, and what are we doing here? So I'm going to do 1, 2, 3, 4. First of all, we create the canvas, so it's a blank canvas. So I call it canvas dot canvas, and I'm going to call it some name. So I'm going to say hello PDF.pdf, just some name. .pdf, right? And now the advantage of this is I can write whatever I want from the system into this, okay? So let's say, for instance, drawstring, and then, we're going to draw a little text box in there, and we just write hello world. So as you can see, any information that you want to write in here, you can plug in here. So ls or uptime, whatever you get from the system now, you can write it into this PDF, and you can start then to generate reports. So that's really the idea. Then we can say c.showPage. You can also, and save it finally. So c.save. So hopefully when we run this, we're going to have a PDF. So now we do report, right? We just call the function, and then we should be able to get our report. And as I said, in between here, right, between this line and the next line, here just, I'll write a comment, get your data from Linux, right? So whatever you're monitoring, you're creating analysis, reports, etc. You can do this so that, all of this is done automatically for you. You can even do this. So think about, you have cron, right, running several scripts every day, every night. They collect information about your systems. What do? They take that information, they generate these PDFs. They put these PDFs in the folder where you want to show data, and then with the HTTP server that we did at the beginning of the semester, or the beginning of the class today, people can just see the reports, right? So whenever they want to see the most up-to-date reports, they just go there. All the reports are updated automatically. You never have to touch anything, right? You only do it once. Obviously, you check that the information makes sense, but so anyway, that's the idea. So now let's go ahead and take a look at this. Let's see if it works. So we are going to run it. We need to do Python. All right, so did that. So we do ls. Is there a PDF in here? Yeah, there it is. Hello PDF.pdf. So let's try to open that file. So I'm going to go to desktop, and then 372, and there's a PDF in here. So I need to double click on it. There it is. Hello world. You see that? So the 100 by 100. The 100 by 100 possibly just means the position in the page, right? But this is pretty handy. Now imagine how great this is, right? You use cron to have lots of scripts checking all your local computers, all your servers for all kinds of details. this all, you know, you collect all that information, you analyze it in however you want, create these PDFs, put these PDFs in the folder in question, right, in the folder in question. And now we can go, if we go back to the terminal, we can run that script that we ran at the beginning. Where is it? Wasn't backup. It was this one, right? All right, so the problem, it's not running now, it's because of the socket. I usually have to kill the terminal before so the easy solution to this is just to change the socket. So I'm just gonna use 8001, because right now that socket should be busy. So the process is still there, locked. So now if I run this, you see now it's listening on 8001. So now if I go to the browser and I do, oops, and I do 127.01, and then just 8001. And you can see now you would generate all your reports. So imagine now, you know, everyone in your organization just comes here and they click on this, and boom, they got the reports. Nice. And you have to do not much, just create the scripts initially. All right, any questions on this one, guys? Any questions?
I don't think so.
Could I see the code for 1 second? For hello, the create report.py.
Say that again, I'm sorry, I couldn't hear you.
Could I see the code again for create report.py real quick?
Sure. Oops, I ran it. There it is. You can take a look at it. So we can pause for a sec. Just take a look at the code.
I got a screenshot. Thank you.
You got it? All right, great. Now, can you do more complex things with this? Sure, you can do a lot of things with it. You know, you can collect, you would collect, what is the information you would collect? You would get the date and time, right? You would want to date and time stamp your reports so they have date and time. You know, you could add information into it just to make it more advanced. So we're not going to go into all the details of it, but at least this gives you now some intuition as to what else you could do, okay? So that's pretty useful, I think. All right. You could take information from log files and then summarize it somehow and also show it here. So that would also work. All right, so what else? All right, so I think that's good enough there. We've covered quite a few. We've covered geo-locate already as well. Okay. Just want to make sure that I'm not missing anything important. So we've compressed. Right. So I think now we are ready to do the map reduce one, right? So remember, that's a more complex problem. So we'll take a look at that one. So the goal here will be to count the number of words in several documents and then just kind of print the summarized version of them. So let's do that. Okay. So to do this, I'm gonna close this script then. Do clear here. So remember, the first thing we need is we're gonna use cat. We're gonna need some files. Okay. So this problem I will assign for you guys to work on. So I'm not gonna finish this one, but I will give you the scripts. You just have to do the pipeline. So we need basically we need a pipeline here. We're gonna count words, so we're gonna have two scripts. Let's start there. We're gonna have two scripts. One is called mapper.py. Let's call it mapper. And one is called reducer. So we talked about this idea before a little bit, where we said, you know, we're thinking about things in parallel, right? We're thinking about things in parallel. So let's do reducer. All right, so if we go back to the whiteboard now, go back to the whiteboard. Remember what I said on Monday, a poor man's, poor woman's, you know, poor person's Hadoop or parallel computing. So what do? This is our own version of this. We have 4 computers, right? Or we can have more, ... We can have as many as we want. We want to count words, right? We have all these words, all these books, you know, entire library of books. And if you don't think in parallel, what you might be inclined to do is just with one single computer, you do all this work. And it's going to take forever. However, you can divide out the work. So what you need to do is you break the books into 3 groups, right? And then you send one here, one there, and one there. So the data is now stored. Remember what we talked about. We want the data to be stored in the computing unit. Once the data is there, what do? Each one of these will count its books. So every one of these needs to have 2 functions, mapper and reducer. So each one needs to have mapper, and it's the same script, mapper and reducer. Mapper and reducer. All right, so you have the same script in all 3 machines. Each does their own part of the data they need, but this has to be done in parallel. So this is a distributed or parallel technique, okay? And we're gonna try to use Linux as much as possible. So we're gonna try to use Linux to help us solve this problem. For your example, you will need to download, so you need to go, so that this will be one of the problems. You need to go to the Gutenberg.org website, and you need to select some books, okay? You need to select some books, and then you just need to do this on 1 machine. You don't need to have 4, although you could if you wanted to. Then you're gonna feed the book, so you do something like cat books, and you pipe them into the mapper and reducer functions on the terminal. And then you do all, you know, you follow a parallel technique so that at the end of the day, you would run the books through mapper and reducer, and you would get the results. You would get a summarized version of the results from each Linux machine. And then finally, that can be sent to a central computer, which combines everything. And then the central computer then gives you the total words, right? So it gives you total per word. So it would give, like, you know, because you're going to send here that your result for the was, let's say, 1,300. And then this one will say that the result for the was 5,000. And then this one would say that the result for the was, you know, 7,000. So usually it returns things that are key value pairs. You see that? And so the final computer just has to add all these. So it's going to say, oh, okay. So the finally was, because, you know, computer A reported 1,300, computer B reported 5,000, computer C reported 7,000. So I just need to add them. So that's what, 12,000, 13,300, correct? I'm doing that right. And that's it. You see that? Now, you've efficiently, now this only works when you have extremely large data sets, right? So basically the data sets are so big that if you just do it on one computer, it's going to take forever. So it makes sense to break the data in parallel and do it in separate computers. Okay, guys, does this idea make sense, guys?
Yeah, it makes sense.
Perfect. So now the key issue is that we have to think in parallel now. So the writing of the code for mapper and reducer is going to be a little bit different. Okay, we're not going to code like you code sequentially. This is not sequential coding. Okay, so the first thing we need to do is we need to break every word into a unit. We have to do that because of the way we need to do the count. So we need to create key value pairs. Okay, the mapper does that. So for instance, now you're in one single computer. You're in one single computer. And you have the books that are assigned to you. Let's just say book 1, book 2, book 3, ... book n. So you have those books. Now you have to count the words in all of them. So the key thing that happens is you have something like the cat is the best. So what you do is you need a function called mapper that takes that as input and produces key value pairs like so. It'll say the 1, cat 1 is 1, the 1, and best 1. You see that? That's the first step. You create every word will have a 1. That kind of just means this word exists. That's really what it means. And then once you have these words, the next step is you want to sort them. So I want to sort them in a way that they're all together. So for instance, I do, I think the cat would be the first, cat 1. Then what's the next? No, B is the first one, right? So best is 1. You guys can help me out. What's the next one? So I did best, cat, is, right? Is the next one. And then the. So there's 2 the's, right? So the 1, the 1. Do you see that? We do this sorting. This is a sorting because that way it makes for very efficient computation. If you don't do the sorting, what do you have to do? For every word, you have to go down, right? You have to say, all right, now I'm analyzing the. So I have to, okay, is this a the, is this a the, is this a the, is this, you know, and count it. Then I'm in the word cat. All right, again, is this a cat, is this a cat, is this, you know, and then is, you know, and that's very highly inefficient. So that's highly inefficient, so you do not want to do it that way. Instead, you just do a sort, and the sort can be done in the Unix terminal itself. So if we do the sort in the Unix terminal, this is the input, this is the output. Now we don't have to do that for loop, right, that I just did, because we can just say, we just need some logic that says, well, I'm in this word. Keep the next word, if the next word is the same, count it. If not, make that a total and transition to the next one. You look at cat. If the next word is cat, add it. Otherwise, that's it. Does is have other words? No, it's, you know, so keep going. Now the, I grab 1. Okay, is the next one the? Yes. Okay, so add it. So now the is equal to. Is the next one the? No, it's something else. Continue. And that's the reducer. Okay, the reducer just takes the ones and now converts them into this. And that's very, very much a very basic way of thinking of how to write scripts in parallel. So you guys, you know, as you know, you're moving into an era of parallel computing, right? So you're not going to be able to escape that. because there's just way too much data out there. And you know, companies nowadays, everybody says companies now, they're all information, they're all knowledge and everything, which is true, right? So you know, so there's a lot of information that you need to process, and so you know, you could build your own parallel computing fairly easily with Linux just by doing something like this, okay? Because we've learned about redirection, we've learned about piping from the file system analysis lab and so on. All right, so now that we've talked a little bit about this, let's just get into the code. And you will see actually the reducer function is a little bit harder, I'll admit, but the mapper function, it is so easy. So reducer.py. So let's get into those. So if we don't finish this today, then I may not assign homework yet, but I'll assign it. All right, so let's go ahead and switch back to our virtual machine. So we're there. Okay, so now, okay, so let's think a little bit about this one. All right, so let's try to think about the mapper function. Okay, so how could we do a mapper function? So let's mapper. All right, we can come here. What do we need? We need some data, some input. And so how do we get those inputs? We have to assume that we're getting that from the system. So we're gonna need a library called import sys, right? And then we're gonna say now sys.standard in. What is that? This is the equivalent of the pipe. Okay, so whenever on the terminal we do pipe, what is that? A redirection, right? Now, what if I have a script here that says python.py, you know, something, right? The output of that, I can pipe it into the next thing, right? Just like I can do cat, you know, my book1.txt. So I'm going to take that book, pipe it into the script. How does the script grab this pipe? By using standard in. You guys see that? Pretty easy. All right, so then that's all I need to do. So what I'm going to do to grab the pipe from the terminal is I can refer to it. It's all going to be stored in sys.standard in. It's going to be stored in there. Therefore, I can just iterate and say for line in, because I'm giving it all the lines of the book. So for line in sys standard in 1, 2, 3, 4. What do I want to do? I just take that line, you know, it's a sentence. The cat is sleeping, you know, something like that, right? So I need to break it into words. So I'm going to do words equal line dot split. So this usually by default splits on space. So then I also want to get rid of like trailing spaces, etc. So I'm going to do line equal line dot strip. Okay. And then we're going to do for word in words, right? So that's for every, you know, now I have all the words in there for every line. And now I'm going to create the key value pairs. So I'm going to do 1, 2, 3, 4. This creates basically what I just said. So think of the, comma, 1. They're always 1, right, for all the words. And so now I can do just print. Why print? Because when we print this, it will print out to the terminal. And when something prints out into the terminal, we can pipe it to the next step. so that we can do redirection. So now I can come here and I can just say something like, there's a couple of ways of doing this. So I can say percentage S. Now this is a tab, okay? So the tab key, right? The tab key, we're gonna separate these. Instead of separating by comma, I'm just gonna separate by tab. And then I take percentage S, and then percentage, and now this is a format string, so I'm gonna plug in the values. So what are the values? The word, comma, 1. You see that? So that way I have the word, the 1, the key value pairs, and then it's just gonna print a word tab 1. And that's it. That is literally it, the mapper function. So now I'm gonna do that. And now what I wanna do is, I'm going to take one of these files. Which one's the longest? Do you guys remember? Let's try simple web server. Let's just see. So I'm gonna cat simple web server. I have 2, okay? Pipe it into Python mapper.py. Okay, so let's see what happens. Do you guys think it worked?
Looks that way.
Looks that way, right? So I took every word in there. Obviously, you would want to do this with like the books, so that you got all the, cat and dog and all that. So you want to do this. I take any stories that you like, Grimm's, Beatrix Potter, whatever, and just do, children's stories and do this. So now we have the mapper. So if we go to the whiteboard over here, for our parallel computing in Linux, we actually have this, something that looks like that, right? So we just did every computer that received a lot of data, right? Every computer that received a lot of data now has effectively implemented the mapper function, which means all the words in all the books that each parallel Linux commodity computer is using looks like, the 1, cat 1. But we still need to finish by adding the reducer so that we can get, for each machine, the total, right? For each machine, we want the total so that then we have one central machine, and central machine will tally up the results, aggregate everything that needs to be done. Now remember here, you can also use awk. So if you remember, we talked about awk and its power, so you can play around with that, and you have a lot of tools now to do things highly efficient. Think about how easy this is, right? How easy this is to take a cluster of 1,000 computers and be able to process a lot of data in parallel. All right, so now that we've done this, so we've done the mapper, now let's think about the reducer. I'm gonna go back to the terminal, and I'm gonna do reducer, right? Reducer is, now that one's a little bit more complex in logic. Now, what we want to do though, remember the words are currently not sorted, right? So reducer assumes that we're going to sort the words. So we need to do here the sorting part. So we need to sort, right, like that. And then that sort will be piped into the reducer script. So we're going to do reducer.py, okay? Did I do, why is that?
Oh, Python reducer.py.
Hmm?
You were missing the Python in the front. It's not an executable file.
Oh, that's right. I'm sorry. Yes. Thank you. I see what you're saying now. Right. So if I wanted to do this, right, I have to chmod, right? Guys, if I wanted to do that. Otherwise, you're right. I have to do Python. Obviously, it didn't do anything so far because I don't have the reducer script done yet. So that's the next step. So let's go ahead. Hopefully, we'll finish this, I think. So there we go. So now we come to reducer. Now this logic is a little bit more involved, I'll admit. This one is a little bit more involved. But let's work through it. I think we can get it done. All right, so what do we need? We need here import sys again, right? So we'll start with that, import sys, so that we can use standard in. We'll need to have a few control variables, all right? So we need to keep track. We know that the words are now sorted. Remember, we talked about what the sorted looks like. That's a key component. If you don't do that, your parallel will not work. So we need to have our words like this, right? Not like this. This is unsorted, but sorted like this one over here. But our algorithm actually assumes this. All right, so we need to keep track of a few things. We're going to keep a variable called current word, and we're just going to initialize it to none. This is like the null in Python. We're going to have current count. That just means the number of times we have seen the word, the current word. So we've seen it 3 times. We add another one. So current count. And we have the actual word, another word. So that initializes to none. So maybe when we're making the transition, you know, we have another word in question. All right, so we have these kind of created. Now we start with the same thing, for line in sys dot standard in. You see that? For line in sys standard in, we have our way of reading in from the pipe again. 1, 2, 3, 4. Let's clean up the line a little bit. So let's do the whole, let's get rid of trailing spaces. So line dot strip, get rid of that. All right, so that's clean now. Then we're gonna do a split on here. So we're gonna say word, comma, count, right? So we're gonna remember that these look like this. These look comma 1. They all have a 1. And it's not a comma, right? So instead of the comma, there's a tab in there, right? So we need to get split on tab. And so what I'm gonna do here is I'm going to line dot split on tab. Okay, now I have the word and the count. That's really great. What else do we need? Now that count is going to be a string, but we need to perform a math operation, so we need to convert it to an integer. So I'm going to do then int here. Count. Now remember this part then, now the data, because the data is sorted, we can do the following. We're going to check all the words. So I'm going to say if current word equal word, which initially they will be the same, right? Because they're both none. So if current word equal word, what does that mean? it means that you transition from a the to another the, right? So 1, 2, 3, 4. So then that should mean that the current count is incremented. Oops, that should be lowercase. Current count is current count plus 1. Just like that, right? Oh, not like that, actually. It should be, although that would work, it's more appropriate to do the variable count, because, you know, for other problems, it may not be a 1, it could be something else. So this is a little bit more appropriate, so you do that. Else, however, else, 1, 2, 3, 4, what do? What just happened? They're not the same, right? So what does that mean? There was a transition. You just went from the to year, right? Or some other word that follows in the sorting. So you just made the transition. So at that point, then you can, what do? You're done. That means you're done. This means you're done. A transition just happened. So then you can say, for current word, if it's not none, right? So if current word, basically it means that because remember, for the first time, current word will be none. And so you don't want to record that. But every other time after that, it'll be an actual word. So you just say if current word, which is the equivalent of saying if it's not none, then you can print out the result and send it out to the terminal. So then 1, 2, 3, 4, and you just do print. Remember, this just goes out to the terminal, so it can be redirected. And now we can say, same thing we did before, %s, tab again, %s, percentage, and then we have, this is a format string, and then now what do we say? Current word, comma, current count. You can see this will give us the total, right? This will give us the total, and so now we have, the equal 3. You see that? So that works really nicely. Then what else? At that point, we printed out the word, and then we need to reset everything, right? So we need to reset everything. So now what do we say? What do we say? We have to tell current word to move to the next one. So then current word will be equal to word. Okay? Current word will be equal to word because we just grabbed a new one, right? We just did the split, and then we have that word is now the new thing we just looked at. Therefore, that word gets assigned to current word. We need to reinitialize the counter, right? So we say then current count is equal to what? Let's see if you guys can tell me. What is current count equal to at this point?
Zero.
Yeah, I think that you're reinitializing it, but actually we already have, because we're in the new one, in the new transition, so we actually have the new count, which is 1. Do you see that? So we assign it count. Since we're assigning the pairs, right? Remember, this is word and this is count. And and your answer was because you're thinking sequentially. These are the little tricky things of thinking a little bit more in parallel. Okay? But that's it. You know, you can see that the code seems hard, but it's actually, that's it. That's pretty straightforward. So now there's one little piece missing here, but I usually like to show that part later. First, let's run it and let's see what we get. All right, so I'm going to save it. Okay. Now, there's a way that we can test this, right, in an efficient way. Instead of doing this, right, we can actually test it in a more practical way by doing, let's do echo. Let's use an echo. And I'm going to say echo some string. So that way I know it's, you know, let's take a string. Foo, Q, labs, foo, bar, Q. All right, so it's just some strange words there. If this works, what would be the output? We would need to get foo equal 3, Q equal 2, labs equal 1, bar equal 1. You guys see that? So let's go ahead and run that. All right, so what do we see? Foo is 3. That's correct. Bar is 1. Labs is 1. But we're missing 1, right? We're missing Q. You guys see that? That we're missing 1?
Yeah.
And the reason why that is probably that Q is the last word. If you think about it, you know, because of the sorting, it probably put bar first, then foo, then labs, and finally Q. And so the way that the code was written is missing that little piece. And that's why I left this comment here. We just need to add one more statement that says, you know, output, the way this logic works, it forgets to print the last word. So output the last word. All right, and so for this one, we can just say for the last one, if current word equal word 1, 2, 3, 4, print percentage S tab percentage S percentage, and then we print current word, which current word should be the last one, right? Because it's the current. So current word, comma, current count. So if we've done everything right this time around, it should all work. So let's go ahead, Control X. All right. And did it work?
Yep.
It did, right? So foo is 3, bar is 1, labs is 1, and Q is 2. And you're done. Now think about it. It seems pretty trivial, but the question is, if we go back to our notes over here, is that if we had, you know, as companies like Google and Facebook and Amazon and Apple and all those companies have tons of data, right? Tons of data that it just cannot be done sequentially. Then you have Linux. You have a lot of servers there. You break up the data in parallel. Remember the principles that we discussed. The data and the processing need to be on the same computer. You need to minimize the amount of network, right? So you only save the data once into these. It is really the way that it would work is as you're collecting the data, you already have in mind that you're going to do parallel computing. So it's not like you collect the data and then move it to these servers. You're initially already, you have to save it because you're collecting it. So it's just being sent into this distributed idea of file system. And then now easily you can write these mapper and reducer functions and similar ones. And then you can tackle your problems in parallel by taking advantage of the power of the terminal. Remember, there's no sorting that will be faster than the terminal, right? So these are extremely efficient things. And then you do your mapper, reducer, your sorting, you do your pipeline, your pipe, you can use awk all kinds of things. It now, at the end, instead of sending all, imagine if you had to send in the network 13 or 7,000 thus. That's 7,000 packets at least, right, that you would have to send. Instead, you have an encrypted tunnel, SSH to a computer. You don't send 7,000 thus, you send one, right? Because you do the mapping and reducing on the computer, send it here. This will do the final tally. Done. You did parallel computing, and that's it. What do you have to do? Your first problem is going to be, I'm going to, when I create the link, I'll create 3 problems, but just be aware, if you want to get started, just because we're running out of time, just go to the Gutenberg.org, find some books, and then just do this exercise with the books, okay? So I just want you to do it on your own, and I want everyone to have their own books while they do it. Remember, the scripts are on GitHub, and you can always just get them from there or watch the video again. All right, that's this is a good stopping point. We completed, as far as I think, we completed mapper and reducer. We completed our exploration, if you want to call it that, of Linux for parallel computing. All right, so that's basically it. So I'm going to go ahead now and stop share. I'm going to stop